Imagine, for a single terrifying moment, that the sun simply blinks out of existence. No grand supernova and no slow expansion into a red giant. Just a sudden, silent void where our 4.6 billion-year-old star used to be. Right now, as you sit there, you wouldn't have a clue that anything was wrong. For exactly 8 minutes and 19 seconds, you'd continue your day in the warmth of a star that is already gone. This is because the sun is about 150 million kilometers away, and its light, traveling at a finite speed, takes that long to reach your eyes. But the most unsettling part isn't just the light, it's the gravity. According to the laws of physics, gravity also propagates at the speed of light, meaning Earth would stay locked in its beautiful curved orbit for those same 8 minutes, tethered to a ghost. Then, the clock hits that 8-minute mark, and the world fundamentally changes forever. The sky doesn't just go dark, it vanishes into a deep, absolute black as the sun's photosphere, which usually radiates massive amounts of energy as visible light, is no longer there. You might look up to find the moon, but it would be gone too, as the lunar surface only shines by reflecting the sun's rays. The stars of the Milky Way would become your primary light source, though they contribute only about 1/300th of the light of a full moon. You'd see the planets for just a little while longer as the light they were reflecting from the now extinct sun finally reaches Earth. Jupiter, for instance, would continue to shine for about an hour after the sun disappeared before it too, snuffed out into the darkness. As the lights go out, the very ground beneath your feet would feel the change as Earth's gravitational anchor is severed. Without the sun's 333,000-fold mass holding us in place, our planet would suddenly break its circular path. We wouldn't spin away wildly. Instead, we would fly off in a perfectly straight line, tangent to the point where we left our orbit, like a stone released from a sling. We would become a rogue planet, hurtling through the freezing void of deep space at a staggering 30 kilometers every single second. Within hours, the warmth we take for granted would begin to bleed away into the vacuum. The average surface temperature of Earth is a comfortable 14 to 15 degrees Celsius. But without the sun's constant energy, the planet would radiate its heat away exponentially. By the end of the first week, the global average temperature would plunge to freezing. Within just 1 year, the world would be a frozen wasteland at 73 degrees Celsius, or 100 degrees Fahrenheit. Eventually, it would get so cold that the very gases in our atmosphere would condense. First, the air would turn to liquid rain, and as the temperature dropped further, it would eventually fall as oxygen and nitrogen snow, leaving the Earth's surface in a vacuum. The impact on life would be swift and devastating, because 99.9% of the natural productivity on Earth relies on photosynthesis. The moment the sun disappears, the process stops, and plants can no longer convert carbon dioxide into the energy they need to survive. Most small plants would wither and die within days or weeks. Larger trees might survive for years or even decades because they have massive stores of sugar and energy. But even these giants would eventually succumb as their internal sap and water solidified in the killing cold. Interestingly, we wouldn't suffocate immediately. Our atmosphere contains a massive quintillion kilos of oxygen, and it would actually take humans and animals thousands of years to breathe it all, even if no more was being produced. So, where would we go? Our only hope for survival would be the Earth's own internal heat. Deep in our core, radioactive elements decay, keeping the center of our planet at a blistering 5,000 degrees Celsius. Humans would have to migrate to geothermal hotspots like Iceland or Yellowstone, or move deep underground to stay warm. But while humanity struggled, another group of Earthlings wouldn't even notice the sun was gone. Deep on the ocean floor, extremophiles live around hydrothermal vents that spew superheated water from the Earth's interior. These organisms don't need the sun. They use chemosynthesis to turn heat, methane, and sulfur into energy. To them, the surface could be a frozen block of ice miles thick, and they would continue to thrive for billions of years. In the end, Earth would become a massive spaceship, carrying these tiny passengers through the galaxy. After a billion years of drifting, we might have traveled 100,000 light years, potentially passing near thousands of other stars. There is even a slim chance that our rogue planet could be captured by the gravity of a new star, thawing out our frozen oceans and allowing life to proliferate once more. It is a humbling reminder that the sun is not just a light in the sky. It is the source of our heat, our gravity, and the very energy that drives almost every living thing on this planet. We live in a delicate balance, powered by a star we often take for granted. If you enjoyed this journey into the what if, make sure to subscribe to Curious Lens for more deep dives into the wonders of our universe.